Hey guys, so today we're going to be looking at the quotient of powers property. So what happens when I have something like this? Let's say I have x to the sixth over x to the second power. Well, if I write out what that means exactly, that's just going to be x times itself 6 times on the numerator, right? Because if I have x to the sixth power, that just tells me, well, I need to multiply this x 6 times itself. So that would be the numerator. And then how could I write out x squared in a different form? Well, I can just write it out as x times x. So what can I do here now? I have all these multiplications in the numerator, all these multiplications in the denominator. And what I can recognize here is, well, whenever I have a number being multiplied in the top and the bottom of the fraction, I can cancel these out. So an x will cancel out with an x on the bottom, an x will cancel out with an x on the bottom. And what I'm left with now is these 4 x's being multiplied together in the numerator. So this just gets me equals to x to the 4th power, right? Because that's what this is. X times x times x times x. That's just x to the 4th power over what happens in the denominator when everything cancels, just 1, which is just simply x to the 4th power. So people started realizing when you write it out this way that it's pretty easy to predict what the final answer is going to be if you just look at, for example, in this case, the 6th power on the top and the 2nd power on the bottom. So just by looking at these two numbers, I can actually guess what this number is going to be. And you might be able to figure it out. But let's look at one more example just to paint the picture. So if I have x to the 3rd power over x to the 2nd power, that is just x times x times x over x times x, right? X to the 2nd power is x times x. X to the 3rd power is x times x times x. And now, when I consider what is going to cancel, I'm going to have an x cancel on the top and bottom, another pair of x's cancel on the top and bottom, and all I'm left with is this one singular x on the top. So that's just x to the 1st power on the top and over a 1 left on the bottom. In other words, it's just x to the 1st power. So again, the pattern emerges. The top of the fraction, if it's to the 3rd power, the bottom of the fraction to the 2nd power, then that means I can predict what this is going to be. And if you figured it out yet, the quotient of powers property that we can generalize, and I'll write this over here in purple, is if I have some number raised to some power, we'll call it x to the a power, and then I divide it by that same exact x to the bth power, then I can predict what that's going to be just by subtracting the two exponents. So it'll be x to the a minus b power. So this is going to be our rule. This is going to be our quotient of powers property. And let's use it to solve a couple of examples really quickly. All right, so now let's use this property up here, the quotient of powers property. And right away, in simple examples like this, since these are the same base, I can go ahead and just say, well, the answer is going to be t to the 17 minus 11th power, which is just t to the 6th power. So that's going to be my answer there. Okay, and number 2, we can see here that this is going to be x to the 5th minus negative 3rd power. Right? We want to make sure that we are very careful here if I have a negative exponent, because this negative exponent is going to affect this number. Sometimes people will write just 5 minus 3 and get x to the 2nd power, but that's not correct because that's not what's happening here. Since this is to the negative 3rd, I need to subtract negative 3rd, which is just x to the 5 plus 3, which is x to the 8th power. So same property, just make sure you do not forget your negatives there. And here, what happens if I have a number 3?